All right, here are quiz 5 solutions. Let's see, on question 1, you're given this weird looking function right here, and this guy right here is f. And what I want you to do is draw each of these 3 functions on the 3 different graphs. So in this first one, what I want you to do is think about g as transformations of f. So let's see, this -1 right here, we'll shift it, maybe shift down by 1, and this +1 right here will shift, careful, you might think it's to the right, but it's actually to the left by 1 because the horizontal transformations are all a little backwards. So I think the easiest way for me to do this is kind of grab a couple points, maybe these 5 right here, and each of these I want to go left 1 and down 1. So this one left 1 down 1, this one left 1 down 1, left 1 down 1, left 1 down 1, and left 1 down 1. And then in red, I'm going to attempt to connect the dots using the same shape as I have in blue. So it looks something like this, and this turns over to there, and then goes up to there. That's probably going to be hard to see my solutions in class when they're all black and white, but maybe in color you can see them. So let's see, this one we got 2 transformations. This +1, which we've seen before, this is going to go left 1, maybe shift left 1. This negative out here in front of the function means we're multiplying all the heights by -1. So we're going to flip over, we're going to flip it vertically. So flip over the x-axis is what this does. So we want to go left 1 for each point and then flip over the axis. So this point right here would end up there. This guy right here would go left 1 and then flip, just stays where it is. This guy left 1 and then flip, so down to there. This guy right here goes left 1 and then flip, so it stays where it is. This one left 1, flips down to here. And now I got to try to draw this upside down. Let's see, these 3 make the kind of half circle, so it looks something like that. And then down to here, and then this little tail here goes something like that. Not the greatest drawing, but as long as you're something close to that, you're golden. And the final one, let's see, we got 2 more transformations here. This -x flip over the y-axis. And this 2 right here is a vertical stretch times 2, maybe by a factor of 2. Okay, so one last time. Let's see, it turns, since one's vertical and one's horizontal, doesn't matter what order I do them in. So let's see, flip over the y-axis. This point, if you flip it over the y-axis, it stays right there. If you stretch it vertically by a factor of 2, it goes up there. Let's see, where was I? This point right here, if I flip it over the y-axis, so let me make sure we still see that point up there. That came from this guy. This guy, if I flip it over the y-axis, it goes over to here. And then I stretch it vertically by 2, it just stays there. So this guy goes to here. And similarly, what used to be there goes to here. Okay. So really, this whole part of it, this half circle here, is kind of immune to this transformation right here. Anyways, this guy right here, I want to flip it over the y-axis. So that flips it over 1, 2, 3, 1, 2, out to here. And then stretch it vertically by 2, so its height instead of being 2 goes down to 4. So that's this guy right here goes way down to here. Finally, this guy here, 1, 2, 3, 1, 2, goes over to here if you flip it over the y-axis. And then if you stretch it vertically by 2, its height goes from 2 up to 4. Alright, now all I have to do is try to connect those dots. Let's see, from here to here were these 2 dots right here. So I'll connect those with a straight line, straight-ish line. This, and this go to this, and this. So I can connect those with kind of a stretched out circle. Something like that. Almost got it. And this guy that was right here ends up down here. So what I got to do is pick this up and kind of have it curve down to there. Not the greatest drawing, but get the idea. Meets all the transformations. That sucked. Sorry for you guys having to do that. Number 2, we're just supposed to figure out if these are even, odd, or neither. This isn't quite as bad of a problem. So to figure out if something is even or odd, what you want to do is figure out, so I'm calling these things h1 of x and h2 of x. Okay, so what I want to figure out is h1 of negative x. And the way you figure that out is you put in negative x everywhere you used to see an x. And now we want to evaluate this to figure out, is this equal to h1 of x, or is it maybe equal to the negative of h1 of x, or neither of those things? I think it'll turn out to be neither. Let's see, the negative of x squared is just equal to x squared. And then I got minus x here. So h1 of negative x is this guy, and this guy is not the same as h1 of x, not h1 of x, because h1 of x has a plus and this has a minus. And it's also not negative h1 of x, because negative h1 of x, this would be a minus and this would be a minus. So it's neither of these things, so it's neither even nor odd. This one here is a little bit tricky. You look at it and you see all the odd number exponents, you might think it's odd, but I think it turns out that it's not. It turns out to be even. The way you figure out, same idea. This right here is h2 of x, so to figure out if it's even or odd, you figure out h2 of negative x. So let's see, that's negative x cubed divided by negative x to the 5th plus negative x to the 7th. So what's this? Negative x cubed is the same as negative x cubed. So negative x cubed is the same as negative x cubed. Maybe the intonation tells you where the parentheses are there. And same idea down here. This is negative x to the 5th, because we're multiplying a negative times a negative, 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 negative 5 times makes it negative. And same idea with the x to the 7th. So then the question becomes, okay, this mess that I have right here, is it the same as h2 of x? Is this the same as this? Turns out it is. One way you can see that is you can factor out a negative from the top and a negative from the bottom. And then these two negatives cancel out. So what we have is x to the 3rd over x to the 5th plus x to the 7th, which is exactly h2 of x, equals h2 of x. So what did we just figure out? We figured out that h2 of negative x is the exact same as h2 of x. And that right there is our criteria for being even. So this, maybe thus, h2 of x is even. And that is the end of this quiz.